So, hello students. Today we are going to start with the first lecture of our electromagnetic field. And before starting, what is first of all we have to know what is electromagnetic fields. So, electromagnetic fields is all that is dealing with the electric field and magnetic fields. Okay. And we know that we have mobiles, and its network is all over around us. It has lots of waves, okay, that is traveling from the receiving end to the sending end. So first of all, we must know that what are the various applications of this subject, that is electromagnetic field theory. So what are the various applications? We have listed down here. The first application is the analysis and the design of communication systems like satellite communication, TV communication, wireless communication, mobile communication, microwave communication, etc. So this subject deals with all the types of communication. That means all the backend calculations in these type of communications are done in the form of electric and magnetic fields. That is for the E and H vector. So this subject only E vector and H vector. Okay, E vector means your electric field and H vector means your magnetic field. Okay. Sometimes this can also be done in the form of B vector and B vector. This we are going to study in this subject. Second application is analysis and design of transmission lines and waveguides. Okay, that all types of antennas that are related to your mobile antennas or TV antennas or radio antennas, all the are all different types of waves of radiation therapy. So I written here also radiation therapy on the body, on the human body, like EEG, ECG, all that have related with the electromagnetic fields. Next is radars, or sometimes the radars that are associated with the air travel system. Okay, so that radars are also deals with the electromagnetic theory. Then radiation therapy, then laser technology, it also depends upon the electromagnetic field theory. So these are the various applications that are related with this subject, that is the electromagnetic field theory. And we are going to cover topics of our syllabus like one, starting with the del. Del is, this is the symbol. So the various applications for the electromagnetic fields are, the first application is analysis and design of communication, like communication, TV communication, wireless communication, mobile communication, or microwave communication, etc. Okay, so in the various types of communication system, the electromagnetic fields are used. Theory of electromagnetic fields are used. Then the analysis of and design of antenna, transmission lines, and waveguides. So all type of designing based on these electromagnetic fields is done for antennas, then transmission lines, etc. Then the third application is related to the biomedical systems. Then weather forecast, radars, all types of radars that are also related to the with the airways also. Then the radiation therapy, then lasers, etc. So these are the various applications related to the electromagnetic fields. Going to with the basic analysis or basic mathematical formulation before actually deals with the electric field and magnetic fields. So first of all, we must know that what is del. Before starting with actual dealing with the electric and magnetic fields, we must familiar with these terms: del, gradient, divergence, and curl. Okay, so what is del? This is the symbol of del. Del is also called as nebula. Okay, this is also called as nebula, and this is called as, and this is mathematical formula at curly by curly x of I cap, curly by curly y of j cap, and curly by curly z of. And what is I? Are the space. Okay, and we generally represent these other, like here it is j, and here it is k cap. These three unit vectors are 90° with respect to each other, and these three are the unit vectors of three-dimensional space. And this one represents curly by curly x. This is the partial differentiation with respect to x, partial differentiation with respect to y, and partial differentiation with respect to j. Now, as you have seen here that here I, j, k are there in the formula. Okay, so this means that del vector quantity, and it has both magnitude as well as direction. Okay, it is a vector quantity. And now the next is here. What is gradient? Yes, gradient is del phi. There is no dot product, there is no cross product. The gradient is del phi, where phi is a scalar quantity. Where phi is a scalar quantity. Okay, so how it now formulates for the del phi? So del phi can be written as, or it can be written as like this: of phi into I cap plus curly by curly y of phi into j cap plus curly by curly z of phi into k cap. Okay, so this is the mathematical formula for gradient. Okay, and here also in this formula I, j, k unit vectors are there, so it is also a vector quantity. Also a vector quantity, and generally we write it as scalar is a vector. The gradient of a scalar is like this here, and then do the square root of this. So this is the magnitude of this vector. Okay. Now the next is the physical interpretation of gradient. Physical interpretation of gradient. That what is the meaning of physically? What is the meaning of gradient physically? What does this relates? Yeah, what is this formula? Depends upon what quantity. Okay. So physically depends that your temperature. Let us suppose we know that ki phi is a scalar quantity. Okay. So it may be temperature. So what does this d phi by dx or d curly phi by curly y or curly phi by curly z? So this represents, it represents change in temperature Okay, so this represents your change in temperature with respect to x, y, and z. Z. So this is the distance in the respective coordinate axis. So if there is here x, y, and here is z. So these are the axes represented in the three-dimensional space. So if phi is any scalar quantity, say temperature, so curly phi by curly x, curly phi by curly y, and curly phi by curly z represents your change in that physical quantity with respect to distance. Distance that is represented by these three axes, x, y, and z. Okay, so this is the physical interpretation of gradient. That and the resultant del phi here represents temperature gradient. Okay, because the gradient of temperature is taken here. Okay, so that's why we represent this term as temperature gradient. Okay, the single phi represents your temperature and del phi represents your temperature gradient. Okay, that means the change in temperature with respect to distance in the three-dimensional space. Okay, so this is the physical interpretation of any scalar quantity. Okay, you can take here the example of any other scalar quantity also. Okay, so what does this represent? It represents the change in the that scalar quantity with respect to the distance in the three-dimensional space. Okay, with respect to x, y, and z. Okay, so this is your. Now the next term is formulations for these divergence and curve. Then we do some numericals based upon these. The gradient is del phi, but divergence is taken off for any vector quantity. Okay, and the formula for divergence is for you see any vector a vector. Okay, del dot a vector, and a vector is can be written as ax into I cap plus ay into j cap plus az into k cap. Okay, this is how any vector quantity can be represented. And we know that vector quantity, if any vector quantity is there, so that means it must have their associated unit vectors also. ठीक है, तो उसके साथ उसके यूनिट वेक्टर्स भी होंगे. So I, j, k are their associated unit vectors for ax, ay and az. So ax may be any term in terms of x, y, z also, or simple mathematical value may be there. ठीक है, like ax, it may be 2i plus 3j plus 4k. It can be like this, any vector. ठीक है, or it can be written as like 2x I plus 3y plus z into j plus 4x plus z square into k. It can be written like this. Okay, but the necessary term is that there must be some unit vectors. So only then it can be represented. But in general, we can represent simply like az. तो in general हम इसको ऐसे ही represent करते हैं. Now what is the divergence? Dot a. So what is the vector quantity? Curly by curly x I cap plus curly by curly y j cap plus curly by curly z k cap. This is our del. Then what is a vector? Take the dot product. Here we have to take the dot product. Dot, then ax I cap, ay, j cap, and okay. So here it is the dot. And for the dot product, we know that he that the angle is 0 degree. That means the cos of that is 1. So I dot I and j dot j or k dot k is equal to 1. Okay. And j dot k dot I is equal to 0, because here the angle between them comes out to be 90 degree. And for dot product, we know the formula, that is magnitude of one vector multiplied by the magnitude of other vector multiplied by cos of theta. ठीक है, and cos of theta, theta is, if theta is 0 degree, only then the quantity is unity. If the theta is your 90 degree, like in these vectors, the answer comes out to be 0. Then dot a comes out to be simple multiplication curly ax by curly x plus curly ay by curly y plus curly az by curly z. Okay, so this is your mathematical formula for as you have seen here, I, j, k unit vectors. Okay, so that means it is a scalar quantity. Okay, it is a scalar quantity. So we can generally write it as divergence of vector is a scalar. Write it like this. Divergence is a scalar. What is the physical significance of this divergence? What does physically it means? ठीक है, जैसे हमने बोला था कि ग्रेडियंट, तो ग्रेडियंट के केस में हमने एक स्केलर की एग्जांपल ली टेम्परेचर. सो ग्रेडियंट मींस चेंज विद रिस्पेक्ट टू डिस्टेंस. नाउ व्हाट इज द मीनिंग ऑफ दिस डाइवर्जेंस? ओके, सो डाइवर्जेंस इज व्हाट इज डाइवर्ज मतलब फैलना. ठीक है, एंड फॉर दिस divergence, so we simply represented as if there is any positive charge. Okay, if there is any, I'm going to write it here. Of lines diverge from that positive charge. Okay, electric field of lines diverge from that positive charge. For this divergence is equal to a positive divergence is there. Okay, and if there is any negative charge, if there is any negative charge, then the electric field of line is coming towards this negative charge. Okay, and here we said that divergence is, this is divergence is negative. Okay, but if there is positive charge, negative charge also. Okay. Charge electric field of lines diverge like this, and for negative away. Diverge means going away from this positive charge and coming towards the negative charge. Okay, coming towards the negative charge. So for this type of category, your divergence comes out to be 0. If the number of lines going away from the positive charge and number of lines coming towards the negative charge, so that means the divergence is 0. For the positive charge, positive and negative, then the divergence comes out to be 0. And the divergence is represented by this formula. And it's a it down in the bold lines. If the divergence of any vector is 0, then that vector is called as solenoidal vector. So there are lots of numericals. This is the going away from any charge, so we said that that is a positive divergence. Okay, if the lines coming towards that charge, so we say that the divergence is negative. So what is the meaning of that negative divergence? So negative divergence means convergence. Okay, so this negative divergence, so this is also said the convergence, also called as convergence. And if the positive and negative lines are equal, so we said that the divergence is 0. And for any vector, if the divergence is 0, so that vector is called as a solenoidal vector. Okay, so that vector is called as solenoidal vector. The divergence. So the next topic is curl. Curl means, curl means the multiplication of vector with a vector. Okay. So the formula for curl, del cross A vector. Here again we can take the A vector as same जैसे हमने divergence में किया था, that is ax into I plus ay into j plus az into k vector. K क्या axi plus ayj plus az k. Curly by curly y, curly by curly z. The third row is for the vector ax, ay and az. Okay, now simply you have to solve this determinant. So how to solve the determinant? Like cross product of this minus this, that is curly of az by curly y minus curly of ay by curly z, like this. Okay. And next term is j cap curly of az by curly x minus this one curly of ax by curly z plus k cap, then cross product of this with this, curly of ay by curly curly y. Okay, so this is the final formula for the del cross k, and as you have seen here in this formula, there is I, j and k vector unit vectors are there. So this is a vector quantity. Okay, this is a vector quantity. So that means curl of a vector is a vector is a vector. Curl of a vector is a vector, and its physical interpretation is that it represents, the curl represents the rotation of a vector around its axis, that how much that vector rotates around its axis. Okay, so the physical interpretation, this represents the rotation of curl of any vector is 0, so that means that vector is irrotational vector. And if if del cross A vector is not equal to 0, if del cross A vector is not equal to 0, then this is a vortex field. It is termed as vortex field. These are the two conditions. If del cross A vector is equal to 0, then this represents the irrotational vector A vector. If del cross A vector is not equal to 0, then this represents the vortex. Okay, and the curl of any vector is a vector. Okay, so this is all about the basic terms, that is del, gradient, divergence, and no. Now let's do some numericals related with this. Simple numericals. Have to prove that del dot E vector is equals to 0. This is you have to prove. And what is E vector? E vector is equal to, that is Ex into I cap plus Ey into J cap plus Ez into K cap. Okay. And what is Ex, Ey, Ez? These are given in the question. That is 6xy into I cap plus 3x square minus 3y square into J cap plus 0 into this last term is 0. And now just take the divergence. So del dot E vector is the curly E by curly x plus curly E y by curly y plus curly E z by curly z. This is the formula for divergence. And just put down Ex. So here it is curly by curly x of 6xy plus curly by curly y of 3x square minus 3y square plus third term comes out to be 0. And what is the partial for this? So with respect to x, we have to calculate. So it comes out to be 6y plus here the partial derivative with respect to y. Okay, so the first term it comes out to be 0, and for this term this comes out to be minus 6y. Okay, and third is 0. So this 0. In this way, you have to do the numericals related with the divergence. At 1, 2, okay, then find del dot A vector it is del dot A vector at 1, 2, 3. So your next question. And you have to apply here the condition for irrotational vector, that means del cross V vector is equal to 0. This is the condition. Okay, now just solve it like here it is curly by curly y, and y component is bx minus 3y plus z. Okay, and k cap, here it is curly by curly z, and here it is 4x plus cy plus 2x. Okay, just solve this determinant and equate it with the zero vector, null vector. Okay, so zero vector means it is 0 into I cap plus 0 into j cap plus 0 into k cap. Okay, when you solve this and equate it with this, you got the values for A, B, and C. Okay, just this numerical you have to do by yourself, and from this numerical just calculate what is A, what is B, and what is the value for C. Okay, so this numerical you have to do it by yourself, and this is all for today's lecture. And in today's lecture we have done the different topics like del, then divergence, then gradient and curl, the conditions for the solenoidal vector, the condition for irrotational vector, what is a vortex field, Okay, different numericals based upon these terms, that is del, divergence, gradient, and curl. Okay, and so this is all about today's lecture. Thank you. So the answer for the fourth question is, it is A is equals to 4, B is equals to 2, and C is equals to 1. So this is final answer for fourth question.